So today we will start the new chapter, which is the chapter 2. I'm telling this is as a module 2 because in the first module we have seen the introduction to control systems. The basic of control systems have been discussed so far. Now from this chapter we will go to the main thing. Okay, so our chapter name is modeling in the frequency domain. You know, in the control system we can use two kinds of domain. One is frequency domain, another one is time domain. Okay. So to understand this frequency domain, time domain, do you know the waveform? If you know this kind of waveform, that is time domain, right? This is T, this is the A amplitude. So that is the time domain. This one time domain. This one time domain. So if you want to see it in the frequency domain, then it would look like this. That is the frequency domain. Say this could be F1, F2, my F0, something like that. So this is the frequency domain. When the x-axis would be the time, when the x-axis would represent the time, then it would be time domain. When the x-axis would represent the frequency, then it would be the frequency domain. Okay, these are the amplitude actually. These are the same amplitude. These are the amplitude. Okay, so in the mathematically, you can represent the control system in two ways. One is frequency domain. In the frequency domain, another one is in the time domain. In the frequency domain, we have the transfer function. Transfer function, we will see this term later. Transfer function. And in the time domain, we have the state space representation. State space representation. Okay, so these are the fundamental things. Let's move on. Okay, so we'll see this thing between. Okay, so what we are seeing here, a block diagram. Okay, it is a simple block diagram. In this block diagram, see the block diagram very carefully. First one, which color I use? Okay, this one. Here, look at the first block. This is a system. That is the input and that is the output. Let's see, RT. T means time. So this thing is in the time domain. So I have to represent it to the frequency domain. So I will write, instead of RT, I write the RS. And instead of CT, that is the output, instead of CT, I will write CS. S is what? S is representing the frequency, or is equal to sigma plus j omega. Sigma plus j omega. That is a complex number. S is a complex number. We can represent the S domain like this way. Sigma j omega. That is negative sigma. That is negative j omega. That is 0. That is 0. And this is S domain. Actually, in the frequency domain. Okay. That is S domain. We can represent this time domain into the S domain. Okay, sigma, where S is equal to sigma plus j omega is a complex number. Okay, where sigma is the real value and j representing the. Do you know j is equal to what? J is equal to -1, right? J is equal to -1. J square is equal to 1, right? J is equal to square root of -1. So J square is equal to -1. Okay, so what we have seen so far, it is a system. Okay, so this system, instead of we can divide this system into several subsystem blocks. We can divide the system into several subsystem blocks. Okay, we can divide the system into several subsystem blocks. Look at this one. This system can be divided into 3 blocks, 3 subsystems. Okay, so this RT is the input, CT is the output. Okay, and CT also called the control variables. CT also known as the control variables. So that is how we can represent a block diagram. We can divide it into 3 parts, 3 subsystems. One is input, and one is output. Okay, 3 subsystems are there. Maybe more than 3 subsystems could be there. It depends. Okay, so that is a simple example that we can divide this in a single system block into several subsystem blocks. Okay, that is the simple example. Now move on. I'm moving on. I'm moving forward. Okay, another term comes here. Look at that. That is a Laplace transform table. You have to remember this one. Okay, that is the Laplace transform. I think you have studied the Laplace transform in the previous courses, right? In the signal system and in the DSP.
Yes, sir.
Okay. So see the Laplace transform table. If you have the delta is what? In the Viva, most of the guys do not know what is the delta. When I have asked them delta, they have answered wrong. So remember this one, this is the delta function. Right. This is the delta. Just impulse function. Okay, so That is the Laplace transform. So if you Laplace transform ft, then it would be fs. Equation is 0 to infinity. All right. 0 to infinity f of t e to the power minus 60 dt, where h is equal to sine of 0. That is simple Laplace transform. So if you do the inverse Laplace transform, then 1 over 2 pi j sigma minus j omega j infinity sigma j omega or something. And here is the equation f of s into est ds is equal to ft. It is the inverse Laplace transform. So you'll see this later when I do the maths. Now see the table. You have to memorize the table. No alternative. Delta. When you do the Laplace transform of delta t, the result would be 1. Delta t is the impulse function. Remember, this is the impulse function. Delta t is the impulse function. Sorry to say, most of the guy missed this one. That is the delta t, which is the impulse function. ut is the step function, right? 1 over s. If you do the Laplace transform of the ut, then you would find the 1 over s. Tut 1 over s square. T to the power n ut n. This symbol is what? Do you know? What is the English term? Just right now I forget. Factorial, right? Factorial. This means what? This means this one. Okay, right? You can also represent it like this. That means n minus 1 multiply it n minus 2, right? Like this. It will continue. This thing, factorial. So t to the power n ut n factorial over s to the power n plus 1. And when it is e to the power minus at, let's see, it is minus a, right? Minus a means here is plus a. And when it is plus a, then here minus a. When it would be e to the power a t ut, right? A t ut, then you answer would be 1 is minus a. Okay. When you apply the Laplace transform to this function, then you will get this one. Your result would be look like this. See, instead of a, you can get another one, another value. Just simple remember. Since if it is e to the power 5t, then is minus 5. All other things are same. Remember this. So that's why this table, understanding of this table is important, because if you know this table, then you can easily apply this, the value of this in your maths. Maths are coming. And see, sine omega t ut. So the value t omega by s square plus omega square. And cos omega t ut is by s square plus omega square. Okay. Oh, by the way, I have uploaded the first slide in your group in the Google Classroom. You can check. And since I am working on this slide, so I cannot upload it right now. After completing that this chapter, then I'll upload it, inshallah. Okay. So in the meantime, you can check the first chapter, and also you can check the videos, and I'll upload the video today, inshallah. Oh, one thing. Do you have collected the MATLAB or not? Have you collected the MATLAB? It is important. Okay, without MATLAB, I cannot move forward. You have to check this thing. Because without MATLAB, I cannot show you the simile. But by using the octave, I can show you the other things, but I cannot show you the simile. Okay. So to understand the simile, you need the MATLAB. You need to install the MATLAB in your PC or laptop. Okay. So let's move on. So remember this thing, this table. Okay. Okay, look at the problem. Example, first example. Example 2.1. The question is, find the Laplace transform of ft. This function is given. See, this is what? This is e to the power minus 80, right? Minus, that means that will be plus. Okay. And ut means what? Okay. Since the time function does not contain an impulse function, we can replace the lower limit of equation 2.1 with 0. This one with 0. Okay, hence, so you can write like this: ft e to the power minus st dt. So instead of ft, you put this value. Okay, so what you'd see, e to the power minus s plus a t. Okay, so now put this one. Since it is minus, then it would be plus. And if you do the integration, then minus will come before this one. Okay, t to the 0 to infinity. Now see, if you put the value 0 instead of t, then it would be 0 here. Then it will be 1. And this is positive, this is negative. So finally, you see this one, a by s plus a. Okay, this is simple integration. Okay, so how it comes? Yes, you need to memorize the formula which we have seen in the earlier sections. Okay. Okay, now partial fraction. So do you remember the partial fractions? Something like that. Something like that. How we can represent this? Okay, how we can represent this kind of things? Like this one. Roots of the denominator of fs are real and distinct. An example of an fs with real and distinct roots in the denominator. Okay, these are the roots. How many roots are there? 2 roots are there. The roots of the denominator are distinct since each factor is based on the unity power. Unity power, s to the power 1 or 2. S to the power 1. We can write the partial fraction expansion as a sum of terms where each factor of the original denominator forms the denominator of each term. Okay, so if you have this kind of thing, then you can write this, write the partial fractions. Partial fraction expansion. That is a partial fraction expansion. Okay, then you will solve it, multiply the both sides by s plus 1 into s plus 2. Multiply the both sides, then you would see this. Okay. So we'll see something like that later. Right now. So if I give you some example, right? So let's talk about this one. 2 by s plus 1 into s plus 2. Right. And here I can write like this. Say a by s plus 1 plus b by s plus 2. Instead of k1 or k2, I can write ab. Now multiply it by this term. Then 2 is equal to a into s plus 1, right? S plus 1 will be a into s plus 2. Because if you multiply this one, s plus 1 will be 1 plus b into s plus 1. Now put some values. Say now s, if you put the s equal to minus 2, then what would happen? 2 is equal to, if you put the s equal to minus 2 times, it would be gone. So here, if you put a minus 2b minus 2 plus 1, that is minus b. So b would be minus 2. B would be minus 2. B would be minus 2. Again, if you put the s equal to minus 1, if you put the s equal to minus 1, then what would happen? 2 is equal to a, right? And this would be 0. Because if you put the minus 1, then 1 would be there. So a is equal to 2. A is equal to 2, b is equal to minus 2. So this one can be written as 2 by s plus 1 into s plus 2 is equal to, instead of a, I can write 2 by s plus 1. Instead of b, I can put the minus here. 2 s plus 2. Now use the fraction. So if you do the inverse Laplace transform, then you find this value. So if you put the Laplace transform here, so see 2 would be there, s plus 1 instead of s plus 1, that means the e to the power minus b minus 2 s plus 2 e to the power minus 2t. Right, and it is there. Okay. So that is the, it is the input actually. Okay, that is the input. So that would be the answer of this thing. Okay, I have explained the thing. They have not done this. So you don't understand this? Guys, have you understood?
Yes, sir. Yes, sir.
Okay. Okay.
Yeah.
Let's
Thank you.
do simple math. Now see this one. Example 2.3. Look at the question. What to say? Given the following differential equation, solve for yt If all initial conditions are 0, use the Laplace transform. So what they have said that use the Laplace transform and solve it. Now see guys very carefully. D dt, right? D by dt, you can represent it by s, small s. So if you have that d square dt by dt square, then you can do what? You can write that s square. So if you convert it to the space domain, then you can write it like this. So they did so. So instead of this equation, we can write what? We can write the s square ys plus 12 s ys plus 32 ys is equal to 32 ut. That means that 32 by s. Instead of ut, you can write that 1 by s. So this equation comes from this equation. Okay. From this equation comes. Now solve the y. So now to find out the y, take this thing common, take the y common, then you get s square plus 12s plus 32 divided by s, this thing. So this kind of thing comes. And if you do the partial, if you solve it, 4 into 8. So s into s plus 4 plus middle term factor. If you do the middle term factor, then you will find like this. S into s plus 4 plus s plus 8. Okay. So if you solve this problem by using the middle term factor, then you will find like this. S into s plus 4 plus s plus 8. Now you have to write the partial fraction expansion. Partial fraction expansion right now. Now see the partial fraction. They use the k, k1, k2, k3. You can use the ABC also. See, they have used what? They have used the k. This is 3 term, s plus 4 and s plus 8. Just use these things. K1 by s plus k2 by s plus 4 plus k3 by s plus 8. So what would be the k1? K do 32 by s plus 4 into s plus 8. Okay. Let me show you this problem. Okay, let me solve it for you. So multiply it by this one. Then 32 is equal to k1 into s would be cancelled out. S plus 4 into s plus 8 plus k2. K2 s would be cancelled. S would be there. S into s plus 8 plus k3 s into s plus 4. Okay, now put the value here. Now put say s equal to 0. Now s equal to 0. If you put the s equal to 0, say s equal to 0. If you put the s equal to 0, then what would happen? This term would be 0. So 32 is equal to k1 into s plus 4. That means 0 plus 4. That is the 4. S plus 8. That means the 0 plus 8. That's the 8. That means 32 k1. So k1. Therefore k1 would be 1. All right. K1 will be 1. Next term, put the s equal to minus 4. Next is equal to put the value minus 4. If you put the s is equal to -4, then what would happen? This term would be 0. This term would be 0. This term would remain. That means 32 is equal to K2 -4. Putting the value. If you put the -4, then it will be just 4. That means -16. K2. So K2 would be -2. K2 would be -2. Again, if you put the s is equal to say -8, then what would happen? 32. If you put the -8 here, this one will be 0. This one will be 0. K3 would be there. Is equal to K3 -8. If you put here -8, then it will be -4. That means that 32 K3. So the K3 would be 1. Right. So K3. So these are the values. Now put these values here. Instead of K1, you have write the 1. Instead of K2, we can write the -2. So -2 come forward. 2 by s plus 4. Now if you want to convert it to the Laplace, yt, this one is would be yt 1 over s. That means the 1, and 2 by s plus 4. That means 2 into e to the power -4t plus e to the power -6 e2. Okay. So do you understand this one?
Yes, sir.
So we have used the partial fraction here. Partial fraction expansion. I think this one easier for you guys. Okay. Okay, now important term, transfer function. After showing you the transfer function, I've gone to discuss today. So transfer function is what? It is the ratio of Laplace transform of the output to the Laplace transform of the input of the system. So if you consider a system, and if you write the ratio of the output of the Laplace transform to the ratio of the input of the Laplace transform, then it would be transfer function. See the figure here, the block diagram. RS is the input, CS is the output. In between, in the inside, there are things. Inside is what? Inside is the Laplace transform. Okay. Here, CS is equal to what? CS is equal to RS into TS. Something like that. See RS. Block diagram. CS. Inside the block diagram, there is TS. So we can write the CS is equal to RS into US, right? Since it is multiplied cascade. So now we can write from here GS is equal to CS by RS, right? We can write like this. GS is equal to CS by RS. Okay, so transfer function for differential equation. See, So what they say, transfer function, find the transfer function of this differential equation. This is given. So first of all, convert it to the Laplace transform, convert it to the Laplace transform. So what would be there is CS sorry, plus 2CS equal to RS, right? Then take the CS common. If you take the CS common, then it's CS plus 2 into RS. So CS by RS. So CS over RS would be what? 1 over S plus 2. 1 over S plus 2, right? So this is the GS. That is the GS. That is the transfer function. So 1 over S plus 2 is the transfer function. So you can write the block diagram here. You can write the block 1 over S plus 2. That is the RS. That is the CS. We can write like this. So that is the solution of this problem. Example 2.4. That is the solution of example 2.4. So, do you understand this one, this problem? Yeah, here or other guys?
Yes, sir. Yes, sir.
Okay.
Yes, sir.
So that is the transfer function. That is very important term. And look at the another example. See, if I put the instead of RT, I put the UT unit step, then what would happen? So if I put the RS as 1 ET, then I have to write the 1 by S into 1 by S plus 2. Then in this case, by using the partial fraction, in this case I have to look at the partial fractions. See here what I have to do. Here I have to write 1 by S into S plus 2 is equal to, say, A by S plus A by S plus 2, right? A by S plus 2. Now do the math. A into S S plus 2 plus B into S. Now, if you write the S equal to 0, when the S is equal to 0, then what it will become? A into 2 I say. Or A is equal to, I write the A is equal to half. Again, S is equal to, say, S is equal to minus 2. Okay, S is equal to minus 2, then what would happen? 1 is equal to minus 2B. So B would be minus half. All right, B would be minus half. Now put this value 1. A is the half by S minus half by S by S plus 2. So 1 by S means 1, and S plus 2 means to the power minus 2B. To the power minus 2B. Instead of CS, I have to write the CT. Okay, that is the answer. That's the answer of this one. Okay. Simple one. So I think you have understood all the problems here. Let me show you one thing. Another thing, we have missed one thing. Yes. And another table is there, which is an inverse Laplace transform, which represent the inverse Laplace transform. Let me show you that table here now. Okay, see, yeah, I'm showing you the another table. See, that is the table. That is another Laplace transform table. Where this table. So, chapter 2, we are in the chapter 2, actually. F of t, this is the definition, this is the linearity theorem. These are the this is also linearity theorem, frequency shift theorem. Some theorems are there. That is the time shift theorem. See the time shift theorem here is here. That is a scaling theorem. And you have to remember this table actually. You have to remember this table. See, 1 by s plus a. So what would be result? To the minus 80 ut. Okay, so 1 over s ut. 1 by s squared t ut. And factorial by s n s to the power n plus 1 to the power n ut. Oh, something like that. Okay. So you have to remember these tables, the terms here. Because if you do remember this thing, then it would be easier for you to apply the things on the maths, on the problems. Okay. So far we have completed the example up to 2.5. The partial, we have seen the partial fractions here. No need all these. We do need the technique how to solve. See, some skill assessment exercises are there. See, find the Laplace transform of ft t e to the power minus 5. So it is easier, e to the power minus 5 here, right? So Laplace transform, you have to find the Laplace transform here. Integrate it and eliminate it. 1 by s plus 5 whole square. And inverse Laplace transform. Okay, so you find this. You can check this at your home. And that is the example of transfer function. Some these things are given also. You can find this thing. Skill assessment problems on there. Something like that. So that is another one. Do you know how to represent this kind of thing? Check this one, okay. Check this here. Skill assessment exercises. I do not have time. Just you check. If you get the result, then you will understand. So, okay. In the assessment, in the final assessment or the mid assessment, I may give you the something from here also. So you check it at your home. Okay. Skill assessment exercises. You can check.
Okay,
it. So check this out. Since it is, if you get this one, then it's okay. If you do not, then something else. Okay. Okay, so I think that is enough for today. We have seen almost 5 maths. So it's sometimes difficult for you guys to cope up